What's up, scholars? We're going to continue with our Chapter 1 review by doing some practice problems. So, let's get right to it. So in this Chapter 1 review with practice problems, we're going to cover 6 things. How to find a counterexample, how to use the segment addition postulate, how to use the distance formula, the midpoint formula, complementary angles, and supplementary angles. All right, so let's get right into it. A counterexample. What is a counterexample? It's an example that proves that something is false. An example that proves a statement is false. So, for example, if I said if the product of two numbers is positive, then those two numbers must both be positive. If the product of two numbers is positive, then the two numbers must be positive. So let's think about that statement for a second and try to decide if it's true or false. And if we think it's false, we'll come up with a counterexample. So, first of all, what does the word product mean in math? This means the answer to a multiplication. Answer to multiplication. The product is the answer to multiplication. So if we multiply two numbers and that answer is positive, then those two numbers must also be positive. I tell you, this is false. This is a false statement. Why? Because those two numbers could have been negative and the product would still be positive. So our counterexample, which proves that this statement is false, would be two numbers that are negative being multiplied together equaling a positive number. So if the product of two numbers is positive, then the two numbers must be positive? Nope, they could both be negative. All right, the segment addition postulate, which was your secret bonus question. I had at least one scholar complete that secret bonus question from the last video. The segment addition postulate. Wait, now let's give these guys some lines there. Segment addition postulate says we could add two segments together and get a third longer segment. So, for example, if I have two segments that are adjacent right next to each other, let's call them X, Y, and YZ. I can say that I could add those two smaller ones, XY plus YZ would equal the big giant segment XZ. So, for example, if XY was 3X and YZ was 2X, and I knew that XZ equaled 10, I could solve for X by saying XY plus YZ equals XZ. XY is 3X. YZ is 2X. And XZ is 10. So I can combine my like terms and get 5X equals 10. And you guessed it, x is going to equal 2. And then I could even plug that back in and tell you exactly how long x, y, and y, z are. If xy is 3x and x is 2, 3 times 2 is 6. If yz is 2x and x is 2, 2 times 2 is 4. And what do you know? 6 plus 4 equals 10. Sweet! Alright, let's move right along. Let's do some distance formula. The distance formula lets us find the distance between 2 points in the coordinate plane. That distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared, and then a square root that whole thing. So all you need are 2 points, and we can find the distance between those 2 points. So let's say the point A is at 0, 3. The point B is at 1, 5. So we'll do a quick sketch just to show you what's going on. 0, 3, 1, 2, 3. That's A. And B's at 1, 5. So we're going to see how long that segment is. Cool. Now let's label our points. It really doesn't matter which one is your first point and which one is your second point. But since I wrote A first, I'll call it my first point. So this will be my x1 and my y1, since every point has an x and a y in that order. And then B will be my x2 and my y2. And we're just going to plug those numbers in to this formula and see what we get. So we got D equals the square root of x2 is 1 minus x1 is 0, all of that squared, plus y2 is 5 minus y1, which is 3, all of that squared, and then square root that whole thing. Doing fine. So D equals, well, 1 minus 0 is just 1 squared. 5 minus 3 is 2 squared. And we know, I can move my paper up a little bit. Totally can. Cool. We know 1 squared is 1. We know 2 squared is 4. So we add those together, and the distance between these two is the square root of 5. Or, if I had a calculator, I could approximate that as a decimal, which would come out to 2.24 if I round to the nearest hundredth. Cool. That's how you use the distance formula. You got your 2 points. You label them x1, y1, x2, y2. Plug them into that formula and solve. Cool. 3 down, 3 more to go. Let's talk about the midpoint formula next. Alright, the midpoint formula helps us find the point in the middle of 2 points. That's why it's the midpoint. That midpoint formula, that point M, that point in the middle, is going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2. That'll give us our new point. So all we need to do to use the midpoint formula is have 2 points. Let's say A is at 0, 3. Let's say B is at 2, 5. And our quick sketch here, 0, 3. That's A. Our point B is at 2, 5. So our midpoint is going to be somewhere in between those two. Let's label these guys. Let's say A is our first point, so this will be our x1 and our y1. B will be our second point, so that'll be our x2 and our y2. We'll plug those numbers into the midpoint formula and find a new point, M, that is between A and B. So M is going to be x1 plus x2 all over 2, which will be 0 plus 2 all over 2. And y1 plus y2, which will be 3 plus 5 all over 2. Well, we know 0 plus 2 is 2 over 2. We know 3 plus 5 is 8 over 2. And we know 2 over 2 is 1, and 8 over 2 is 4. So our midpoint between A and B is at 1, 4. That makes sense. Now, what if we knew the midpoint, and we know one endpoint, and we want to find the other endpoint? So let's say, for example, I keep using A at 0, 3, so let's use A again at 0, 3. Let's say I know the midpoint is at, I know it's at 3, 5. And I want to find the other endpoint, B. So I know A, I know the midpoint. I want to find the other endpoint, which is going to be somewhere over here. Right? A and M and the other endpoint, B, should be somewhere in that general area if M's in the middle of A and that other point. So, the easiest way to find that other point, which we're going to call B, I kind of stacked these on top of each other a little bit too close, is to see how we moved from A to that midpoint M and then continue moving in that same direction to find that B point, which again is somewhere in that circle region. So to get from A to M in the X direction, we went from 0 to 3, which meant we added 3. So we're going to add 3 again. 3 plus 3 is 6. To get from A to M in the Y direction, we went from 3 to 5, which meant we added 2. So we're going to add 2 more and get 7. So that means our new point B is at 6, 7, 1, 2, 3, 1, 2, which is right here. So my graph is not great, but that's how you do it. If you know the midpoint M, stack those points on top of each other from A to M and figure out how to get to B. So we can ignore that little zone that I tried to mark off there. All right, cool. 2 more examples. Let's talk about how to solve with, 3 more examples. How to solve with angle bisectors first. Angle bisector. I got to put an underline there. Great. Angle bisector means we take an angle and split it perfectly in half. So we take an angle, we split it perfectly in half. So that that side equals that side. So, if, for example, I knew this side was 4x, and I knew this side was, let's say, 2x minus 20 degrees. I could solve for x. Is that what I want to say here? No, let's make it plus. 2x plus 20. Angle bisector splits an angle perfectly in half, so that means these halves are equal to each other, which means 4x equals 2x plus 20. So we could solve for x by subtracting 2x here and get 2x equals 20. And let's divide by 2. And we'll say x equals 10. And if we plug that back in, that would mean this 4x degrees, 4 times x, 4 times 10 is 40 degrees. And 2x plus 20, 2 times 10 is 20, plus 20 is 40 degrees. So that's our check. When we plug our x back in, both of these halves should equal the exact same number. Because that's what an angle bisector does. It splits an angle perfectly in half so that each half is equal to the other side. Great. All right, and finally, complementary and supplementary angles. Complementary angles add to 90 degrees. They add up to 90 degrees. So, if I know the measure of angle 1 equals 4x and the measure of angle 2 equals 5x, and I know they're complementary, I know that 4x plus 5x equals 90 degrees. I could solve that by adding my like terms. So x equals 10 in this case. Complementary means adds to 90. Now supplementary, those guys add to 180. So if, for example, I had the exact same situation where the measure of angle 1 equaled 4x and the measure of angle 2 equaled 5x, and I knew they were supplementary angles this time, I would know that 4x plus 5x equals 180 degrees. Combine my like terms, I'd get 9x equals 180, divide by 9, and get x equals 20 this time. Complementary adds to 90, supplementary adds to 180. All right. Scholars, you're doing great. Keep up that hustle. I love you. I'll see you next time.